Good morning class. Today we discuss unit 3rd electrochemistry. Before start this chapter, now let us discuss what is electrochemistry. Electrochemistry is the branch of chemistry that deals with the relationship between electrical energy and the chemical energy taking place in redox reaction. The three main aspects of electrochemistry are electrolysis, electrolytic reduction and electrochemical cell. Now let us discuss the first one, that is electrolysis. Electrolysis is a process of decomposition of electrolyte by passing electric current through the molten or aqueous state of electrolyte. I repeat it again, the process of decomposition of electrolyte by passing electric current through its molten or aqueous state is called electrolysis. Suppose this be a vessel in which suitable electrolyte aqueous solution is there. These are the electrodes which are further connected with cell or battery, and the plug key. This terminal, the positive terminal, is called anode, and this one is called cathode. Anode is generally positive charge, cathode is generally negative charge. Here the aqueous solution of electrolyte. I repeat it again. Electrochemistry is a branch of science that deals with the relationship between the electrical energy and the chemical energy take place during a redox reaction. The three main aspects of electrochemistry are electrolysis, electrolytic reduction, electrolytic conduction, and the third one is electrochemical cell. And electrolysis is the process of decomposition of electrolyte by passing electric current through its molten or aqueous state is called electrolysis. Now let us discuss the mechanism of electrolysis. For understanding the mechanism of electrolysis, now let us discuss some points. The first point is, when electrolyte dissolves in water, it produces ion. I repeat again, when electrolyte dissolves in water, it produces ions. On passing electricity, positive charge ions move toward cathode and the negative charge ion move toward anode. Then the ion loses their charges and become neutral. Cation accept electron from cathode while anion loses electron at cathode anode to become neutral. Thus, oxidation take place at anode and reduction take place at cathode. The conversion of ions into neutral species at their respective electrode is called primary change, and the formation of product after that is called secondary change. In aqueous solution, besides ion of electrolyte, some H positive and OH negative ion from water also move toward opposite charge terminal. Thus, at each electrode, two different type of ion can be discharged, which out of two discharge depends on number one, relative discharge potential. The ion with lower discharge potential is preferred. I repeat, the ion with lower discharge potential, that is the oxidation potential, is preferred and the material of electrolyte to use. So these are the some steps we are kept in mind during the mechanism of electrolysis. Now let us take an example for clarify these steps. Now let us consider the electrolysis of acidulated water. Now we are taking a concept of electrolysis, taking an example by electrolysis of acidulated water. Here the acidulated means in which acid is added. Since we know that water ionized as H positive plus OH negative, and acid, suppose H2SO4 is there, which ionized as 2H positive plus SO4 double negative. Here H positive are moved towards cathode while the OH negative and SO4 double negative move towards cathode. I repeat again, H positive move toward cathode and OH negative and SO4 negative move towards anode. Now here we notice discharge potential of OH negative. I repeat, discharge potential of OH negative is less than SO4 double negative ion. Therefore OH at anode take place like this manner, that is at cathode. First we consider the example of cathode. At cathode H positive ions move toward cathode, thus H positive on gaining one electron gives H dot, that is free radical. H dot plus H dot combines to form H2, that is hydrogen is liberated at cathode. At anode, since discharge potential of OH negative ion is less than sulfate ion, thus OH negative is preferred. Thus we are taking OH negative here. On losing 4 electron it gives 4OH. Now 4OH on gives 2H2O plus O2, that is oxygen is liberated at anode. I repeat it again, electrolysis of acidulated water. First we ionize water as this one, H2SO4 as this one. We notice H positive ion move toward cathode, that is hydrogen is liberated at cathode, while the discharge potential of OH negative ion is less than SO4 double negative ion. Thus at anode oxygen is liberated. Now let us consider the second example, electrolysis of NaCl solution. I repeat again, electrolysis of NaCl solution. Now let us discuss the second example, electrolysis of NaCl solution. Here student, H2O ionized as H positive plus OH negative and NaCl is ionized as Na positive plus Cl negative. Here at cathode H positive and Na positive ion both move towards cathode since discharge potential of hydrogen is lower. Therefore it is preferred. Thus H positive on gaining one electron gives H dot plus H dot on combines to form H2 gas, that is hydrogen is liberated at cathode. At anode, since discharge potential of OH negative ion is more than Cl negative ion, that means Cl negative ion is preferred. Thus Cl negative on losing one electron gives Cl dot plus Cl dot combine to give Cl2 gas, that is chlorine is liberated at anode. Now let us discuss again electrolysis of NaCl solution. At water ionized as H positive plus OH negative, NaCl ionized as Na positive and Cl negative. At cathode H positive plus electron give H dot, it is free radical, 2H free radical combine to form hydrogen gas, that is hydrogen is liberated at cathode. Why are we taking hydrogen here? Because out of H positive and Na positive, discharge potential of hydrogen is lower. The element whose discharge potential is lower must be taken. At anode, Cl negative on losing one electron give Cl dot, Cl dot, Cl dot combine with to give Cl2. Thank you very much.